Hi there, welcome back. Today I'm going to show you how to create HEC-HMS model from DEM data because this latest version of HEC-HMS model is very useful and very effective to generate any HEC-HMS model from DEM data. If you have DEM data, so you don't need to even process this data outside of HEC-HMS model. So they have given us a module that can, GIS module basically, so that will do the job for you. It will automatically delineate your DEM data and it will create that sub watershed or sub basin, and it will automatically create that link and junctions and everything. That's what is pretty convenient. So because of this one, because I already created one video I think more than 1 year ago where I demonstrated how to set up HEC-HMS model, so I'll also give you the link. You will see that, but you can even try with DEM data since I'm working on ArcGIS tutorial for this area, which is basically known as Buffalo San Jacinto watershed. It is just located in Houston City, Texas, USA. You can, you are familiar with that one by this time if you already watched that video on ArcGIS tutorial. So I'll show you how to install the latest version of HEC-HMS model, and then since we already have the DEM, we already processed that DEM data in my previous tutorial on ArcGIS. If you missed that, you can even watch that, how I processed that DEM from download to even projection and everything I did here. Since I already have the ready-made DEM, so I can use that and I can show you how to even create HEC-HMS model pretty quickly, and it is pretty convenient, and that's why I just plan to create this one. Okay, so what I'm gonna do, I'm gonna search for HEC-HMS. Okay, HEC-HMS. The latest version of HEC-HMS is already there. Out there is 4.8 version, so we are gonna download that one. Maybe let me find that, download, and here it is. You don't need to download that beta version. Instead of doing that, we are gonna download this one. Okay, HEC-HMS 4.8, that is already there. I think it's gonna download pretty quickly. It won't take that much time. Maybe it's gonna take a while because it depends on the internet speed. So what I'm gonna do, I'm gonna explain by this time. Since I already have this DEM for this area, so I will use this DEM, and I already converted this DEM from WGS unit to state plane. So my horizontal unit is in feet, and I already converted the vertical unit. Previously the vertical unit was meter, and by this time I already converted that one to feet. So I have everything, whether it is vertical or horizontal unit, both are in feet. So I can directly import that DEM right now, and then I can do all this ArcHydro processes within HEC-HMS model, the latest version of HEC-HMS model. So once it is done, I'll start that processing, and you can even follow that one because it's pretty convenient, it's pretty quick, and it won't take that much time. And you can even today I'll show you very basic trick, so that previously what we did, we even specified the basin parameter, the reach parameter, and everything individually. But today I'll show you how to just do everything at once. If you want to select any method, I don't need to click basin by basin. I'll select all method, like I'm gonna select loss method for every sub watershed. So that's the reality, right? We select the same loss method for every sub watershed, even we select the same routing method for every stream. So previously, the previous version of HEC-HMS, what we did, we just selected one by one, so it was taking a lot of time, and it was kind of laborious, and it was kind of boring. So people just felt like disappointed to set up any model. So what I have figured out, I just went through the manual and everything. I already, because I have idea on that one, I have one video on HEC-HMS model that is that I already published like 1 year ago. So I'll give you the link. You can even watch that one if you are a beginner. So that is even more convenient than the previous one as well. That's why I was thinking that if I can make one video on this one, so other people may find it useful. Okay, let me just quickly check. I think you'll be really amazed that okay, this software is pretty good right now, because they just integrated the ArcHydro and HEC-HMS. So it's really convenient now. Everything we can do within the graphic user interface of HEC-HMS. So that is pretty quick, right? So download is done. So if I double click on that, then it will start installing. You can do the same thing, and maybe it is gonna take a while. Not a problem, okay? And I'll make this tutorial because it is kind of long, so I'll make it part by part, but it's still, the first part won't be like 10 minutes or 20 minutes. It may be, I'll extend up to 1 hour, and then I'll just split it into pieces, so that you can even follow what I'm gonna do. Otherwise it will be too short and you won't be able to follow everything. So I'm gonna even create today in this tutorial how to install, how to create the basin model from DEM, and then I'll even try to run the model by default values, and then I'll show how to even estimate the parameter. So that's the main thing, right? The estimation of model parameter. Okay, so I think it's already done. HEC-HMS, if I search it there, okay, it's there 4.8. okay, I'm just opening for the first time, and here it is. You have to even go through this one, and it's there. Okay, if you want to even install the everything, the install sample project, you can do that, but I'm not gonna do that. Okay, I'm gonna open one new project, and I'm gonna direct it to a folder where I have other. Okay, here is the location where I can put it in that latest version. I'm gonna show you that one. Okay, and then I'm gonna give the name as San Jacinto, okay, watershed, because I'm working on that. The name of the watershed is San Jacinto, and then I'm gonna select US customary because my DEM unit is in feet. Okay, so I can even give the description. It's okay, it is located in Houston City, okay, Houston City, Texas, USA. This is how you can even describe your study area, and I'm creating that. Now what I have to do, I have to go to component and then train data manager. In the previous version it was absent. Now we have this option, train data manager, and then I'm gonna create one train. Okay, so this will be our DEM data. I'm gonna import that from the same directory where I have my DEM. That DEM I already processed it in my GIS tutorial. If you missed that, you can go back and you can watch that one. Okay, so I have that there within latest version of that and HEC-HMS, and you can see DEM data, and it is already in feet. So the vertical unit, I converted it to feet. I'm going to change it to feet, and if I finish it, it's done. Okay, I'm closing that one. Now I have to create that basin model manager, so that will also be a basin model as usual. Then we have to connect it with that train model. Okay, so the basin model, I'm gonna select it here. I'm gonna just make the screen bigger so that you can even see that here, train data. Okay, I'm gonna change it to train, and then if I save it, and I'm gonna skip it because I'm gonna keep the unit same or the projection system same. That's why I'm skipping that. And now you will see the DEM is here. Can you see that? Yeah, of course, it is the DEM. It is the same DEM we have in ArcGIS. So what I have to do, I have to process. Okay, I'll follow the specific rules and steps. You have to follow the same. Okay, so I'm gonna click on GIS, and if I click on there, so I have coordinate system, I have train reconditioning. I'm not gonna do that because I already processed that one. So you can even start from pre-process sync. If there is any sync, abrupt sync, so it will fill that sync and it will make the DEM smooth. Okay, I'm clicking on that, so it started processing that sync, and maybe yeah, it's done. Okay, see, even if previously what we did, we even imported the map, but now you don't need to even import the map or shape file. If you click there, map layer, you can see we have that sink, and sink field we have the train. Okay, this is our main train data. I can even turn it off. We have this sink location where it fill the sink. So what I need this one to turn on, sink fill. Okay, if I keep it turned on, and then what I have to do, the next step is to do that pre-process drainage. So what it will do, if I click that option, it will even calculate that flow accumulation, right? We are familiar with that one, but we did it step by step in ArcHydro in GIS. But now if we click on that pre-process drainage, it will do flow accumulation, and then it will also complete that flow direction as well. We'll see that. Okay, maybe it is gonna take a while, but don't worry, it will finish pretty accurately, and there won't be any problem if you just wait, and if you hold your passion, and definitely it will do the job for you. But for processing any DEM, it was taking a lot of time in ArcHydro and ArcGIS, whatever you use, and definitely I was not satisfied with that one, and I was having different types of problems. I think you also have different types of problem as well, because that was a part of ArcGIS, because we installed that one ArcHydro from HEC-OS site. So that was an external module, so that's why maybe it was taking a lot of time. But now, since it is integrated with HEC-HMS, so it is not going to take that much time. So the processing time is still pretty quick, even if it's taking a while, like few minutes, but still it is not that a big time, right? Long time. Previously it was taking like half an hour or even more than 1 hour, because I can remember that I was processing a similar kind of watershed in Texas, so it was taking like several hours. I was just running the computer, and I was leaving it, okay, run it and create that flow accumulation, and then it was even taking more time for flow direction. That's why I find it pretty convenient, and that's why I'm sharing my experience and knowledge that, okay, if I create one video on this one latest version, so I can even remember what I did previously, and I can even learn new things, and I'm also sharing my knowledge. My only goal is to share my knowledge. Whatever I earn by this time, I learn whatever I learned, whatever I have. So I'm just sharing my knowledge so that other people, even they can learn new things, or even they have the similar kind of idea, but it is kind of sharing or exchanging knowledge that I have. So since I was starting and trying to do hydrologic modeling, and I'll also create another tutorial on TXRR model, that is called Texas Rainfall Runoff Model. That model is basically developed by Texas Water Development Board. So I was working on that model. That model is pretty that is basically run on a Linux machine, and it is written in Fortran code. So you have to compile that and you have to run that. So I have written a lot of and pretty complex script to create the input precipitation, because that model has a weird format, the input precipitation format, because it doesn't have any graphic user interface. So you have to create everything in Linux, and you have to even create all these input files. So that's why I'm thinking I'll create one tutorial. But that model, even it is so simple model, but the output is pretty convenient. So that's why I was trying to compare that model with my HEC-HMS model, and I also compared that TXR model with National Water Model, and also we even run another model called HLRDSM. Okay, that is basically a distributed model. So even I run two lumped model. One was HEC-HMS and another one was a TXRR, and I also compared the result from this two lumped model with another two distributed model. The HEC-HMS is not fully lumped model. It is basically, even it is not even a distributed model as well, it is semi-distributed model. So we have the option, we can create the mesh or grid in future tutorial. Definitely I'll do that, but today I'm going to show you how to even create the lumped model pretty quickly, because most of the time what I do, we create that lumped model and we calculate the basin average precipitation, basin average, other values we need. If we even use evapotranspiration module, we need to calculate that. Even we need to calculate that basin average values, and we can do that using GIS, right? And we can use journal statistics, and I'm creating tutorial on GIS, and I already uploaded the video on how to create basin average values from DEM or any raster. If you have precipitation raster, you can even calculate basin average values, because for running any lumped model we need to do that. And if you want to even run the model for a long time, for example, if you are going to run the model for 20 years, because I run the model for 25 years, the same HEC-HMS model that was for another watershed in Texas, and I run the model for 25 years, and it was lumped model. So what I did, I selected the loss method as soil moisture accounting, other than curve number method or even deficient and constant method. So that's why it depends on your runtime. If your model runtime is very long for several years, so you can't even use that constant and deficit loss method or even curve number loss method. These methods are basically convenient for any storm event. If you have one event, because I'm going to run this model for Hurricane Harvey, right? The storm Harvey that I think everyone knows about that one, right? Hurricane Harvey. So that caused a flooding, huge flooding in Texas, especially here in Galveston Bay, and Galveston Bay is close to that Houston City. So Houston City, this study area was basically underwater for several days, and it was a massacre kind of thing. So that's why everyone is trying to even do some research on that flooding. This is called Harvey, Hurricane Harvey. So I'm going to use that, the precipitation of Hurricane Harvey, because the Hurricane Harvey was not only from the storm event, it is also because of the heavy precipitation. The precipitation was huge, and because of that huge amount of precipitation, the flooding was extended, and it caused a lot of damages, and it also cost a lot of money. So that's why I'm also trying to show you some calculation on Hurricane Harvey, so that you can understand that, okay, the HEC-HMS model is also applicable for any storm event, and it is pretty quick to even set up and run the model. And you will see the stream flow that I'll calculate from that storm or Hurricane Harvey. So it is abnormal. You will see the peak is so high, and when I'll compare with observation data, you will see that, okay, it is pretty close to that observation. That means what is actually happening, reality is the actual flow rate was so high, and it was even exceeding the maximum measuring level. So people, what happens, the gauge was not able to even calculate the bucket that measured the amount of precipitation that was even filled up, and people even didn't be able to even calculate the actual amount of precipitation that occurred at the time. So that's why we even consider a different reanalysis product. So we'll try to use either gauge precipitation, because we are not going to use a distributed model here. So I'll create the same model as distributed, and I'll do the processing, and I'll show you how to even create that graded precipitation, because it needs some processing, some scripting. I'll show you how to do that, and then you'll be able to run both model, either it is a lumped model or distributed model. But you have to follow step by step. Since it is not even distributed model, so I'm not gonna even select SMA, soil moisture accounting module as loss method, because that needs a lot of parameter to estimate, and I'll show you how to even estimate the model parameters. So setting up a model is not that big problem, but especially for any study area, the calculation of model parameter is really difficult, and you have to fix those parameters, right? You have to calculate the time of concentration, you have to calculate the storage coefficient, right? And if you select any transform method, the best way is to select the Clark unit hydrograph method. So you have to even estimate the parameter of unit hydrograph. Once you are done with that, and you can even select that canopy method. So what I'll select the simple canopy method, and I'll even select the base flow method as linear reservoir. If I select the base flow method as linear reservoir, then it is the best way to select the base flow, because if you select linear reservoir, then it will even conserve the mass. Okay, it will preserve the mass conservation law. That's the best way to select a linear reservoir for base flow. And for canopy, we will select simple canopy. And for loss method, for this tutorial, for the sake of this tutorial, we'll select deficient and constant loss method. And for transform method, because we will have precipitation, so how this precipitation will be transferred to stream flow, so we need to fix a mechanism, right? So from a depth of rainfall to the flow rate, so we'll use the transform method as Clark unit hydrograph method, and we'll estimate the time of concentration and storage coefficient. But for the sake of running this model pretty quickly, we'll assume, okay, we'll assume the default values, and we'll also select the groundwater, okay, groundwater bucket. We'll select two different types of layer 1 and layer 2, because we need to generate the base flow. This base flow basically comes from that seepage and percolation. See, we are done with that flow accumulation and flow direction. If I open the map again, you can see that now what I have flow accumulation, right? If I turn this off, you'll see that is the flow accumulation. Okay, flow accumulation, what it is gonna do, it's just see, it created this dendritic network, right? So flow is accumulating and it is just collecting from land surface to the stream, and it is just at the end it is following the outlet. And if I just turn this off, and if I turn that flow direction, see, it is even showing the river. You can see the river network flow accumulation was different, and it is pretty easily, right? And yeah, obviously we can see the river, right? The river is clearly visible this time. So that is the flow direction. If we use this information in our background, right, I'm just turning this off and I'm turning on my train model, the main train data. And what I'm going to do, I'm going to even process that identify streams, and then it will ask, okay, what will be the area of the stream we can define in a square mile. So for this case, I'm going to select 50, okay, 50 square mile. So one stream that will collect water, right, one stream segment. So there will be water flowing from 50 square mile. So if I click OK, so it will create that stream network, and it will show you that, see, we have the streams here. You can see that. Yeah, we can see that is the stream we have. Okay, these are the streams we can see. Okay, these are the streams, and based on this stream you can clearly see these are the white, and it is just from white to dark. And what I have to do, you can see the map, GIS map. If I open that map, right, and we can see that we have different types of USGS station, right? We already have idea about that one. If I turn this off, right, these are the USGS station. If I turn it off, and if I just use this notation, you can see we have a lot of USGS stations, but we're not gonna use all of them. What we're gonna use, we're gonna use only few of them, okay? Not all of them, only few of them, okay? Then our model setup will be pretty easy. Otherwise, if we select a lot of station as our outlet, so it will be like hundreds of watershed, so it will take a lot of time to display. But for your research you can do that, but I'm going to show you how to even create those. Okay, if you assign many station, you will have many, and I'm not going to do that. I'm going to show you the step and you can follow that. So here it is. If I open that, I'm going to even add, okay, you can even add any shapefile as before if you want. I think I have that. If I use that USGS, okay, this station, let me show. Yeah, maybe we have that, I don't know. Okay, let me just show you. let me change it to not yellow, even make it bigger. If I keep that way, this one, let me see. Yeah, see, we can see that. Even we can even select other color, red or anything. Okay, then these stations are pretty visible. You can see these stations are pretty visible. USGS, I think we have the same stations there. Okay, if I turn this on and turn this off and on, you can see we have 3 stations, and I can even remember the name. And if I right click and label this station number and increase it, you can see the number, because we'll use that number in our model so that we can remember the name. See, it is there, right? The first one, we'll select this location to delineate our sub watershed. So that is what I'm gonna do. That's why I'm just switching from this window to that window. We have that. So next step, we have to do this one, breakpoint, okay, in order to delineate the sub watershed. And now I'm clicking there, and okay, let me just quickly click that. It is basically what? It is 8073500, okay? 8073500, and keep that in mind. And I'm gonna even rename that one. I'm giving that 500, okay? 500 is okay. So that would be, so zoom in, and then if you click, I'm gonna assign this is one outlet, okay? Based on this one, it will, because we'll validate our model or calibrate our model. So that will be 500. It's okay. And then we have even another one. That one is 700. That is 610. Okay, let me find that one, 610, where it is. So now it is kind of GIS and HEC-HMS mixture of these two. So that's why I'm pretty amazed that we have this option. So why don't I create one tutorial on that, so that other people can be benefited on this one. So that will be 610, and we have another one. And at the last moment, I'll even specify the final outlet as sink. So that is the way. Why I'm zooming in, because I'm selecting that grid, okay, that specific grid. So that is 700. Otherwise it won't create your sub watershed. Okay, so in order to do that, you have to follow these basic rules. And then even we can, if we have many sub watershed, we can even merge them together and we'll make it more simple. So that is outlet. Okay, as before, I just give this name as outlet, and let's see what we have. We have 4 breakpoints. So it will follow this 4 breakpoint, and it will generate that basin or sub basin model. Okay, and what I'm gonna do, I already assigned this one. Go to GIS and now delineate elements, and then it will ask, okay, what will be this prefix of sub basin? I'm giving that as sub basin. Really, this is really interesting. I just I like it. And reach will be reach. Okay, it will start with reach 1, reach 2, reach 3, and insert junction. Yeah, if there is any junction, so it will automatically insert that. We don't need to do anything. Even it will automatically connect. And what will be the prefix of junction? It will be J, and I'm not gonna select this as yes, because we already mentioned that breakpoint, so it's not gonna automatically break that segment. If I click that delineate, it will do the job for us, and you'll be amazed that we don't have to do anything. It is pretty automatic, and it is gonna create everything for us: the sub basin, the network, and segment of river, and everything. And it is pretty quick. It won't take that much time. And what we have to do, if we are not satisfied with that, we'll even merge them together, and we'll even modify as needed. It is not a problem. See, it's done. Can you see that? Really, it's amazing, right? We have this. We don't even need to connect. Previously, it was taking too much time, right, to even generate, clicking this there, and here. Now we have everything ready. Okay, we have everything ready, and if you want, we can even turn everything off. It's possible. Okay, we even turn off that USGS breakpoint and identified streams, and even train, everything. We can even turn this off, everything is possible. And if you select that sub basin, that's it. Okay, so I'm selecting that one so that it is looking like pretty aesthetically good, right? Okay, I'm keeping that. So what I'm gonna do right now, see, we can see we have smaller. If we click, okay, I'm closing that one. If we click there, it is one selected, right? Smaller watershed. So these watershed, basically we have to generate time of concentration, everything we have to repeat. So I'm not gonna do that. I'm just making it simple. So since it is just flowing there, we have the common outlet, and that is also draining to that outlet, right? The junction we have. So I'm gonna select these two, and I'm just merging them together. Okay, so control and that, I selected this one, and then if you go to GIS and then merge elements, then it will merge for us. Okay, now we have only one element, so we'll have one calculation, and see the other sub basin, it's just gone. Okay, so I'm gonna find those sub watershed that have the common, right? We can see here we have some smaller and bigger one, so I'm gonna merge those, only those that are draining to the same point, otherwise it won't activate that merge. Okay, so it is just draining to there, and which one is also draining to there, that point. Okay, is there any other? This one, okay, this one and that one, it has different drainage network. We can put it that way, or even we can merge this one and that one, so that it is draining there, this one is draining here, and that is draining there. Okay, so these are totally different. Let me find if we have any other option, or we can go to other side and let's inspect what we have here. I'm just gonna make it simple this time. It is looking like pretty accurate. Even we don't need that, we can exclude that one as well. So we have one common point. I'm just checking if there is any abnormality or no. Yeah, so we have this one. This is the reach, is pretty accurately connected, and we have the outlet there. We have one from here, so we can even see merge this together because we have the common outlet, this one and that one, right? This one and that one, because these are even draining to that point. So even if you calculate it separately, we have to even sum them up to get the accurate value. Okay, so I'm gonna even merge them together so that our calculation will be simple. And now what do we have to do? Oh, we are done with that one, right? Yes, so we're done with that one. We have only one here, and that is draining to there. We have only one here, it is draining. So that's why I'm checking after creating that one, because it took very less time. So I'm just making it sure that it's working pretty accurately. So we are having only here a smaller watershed. If it is not possible, we can even leave it there, or okay, we have one option. See, that is the option. You have to zoom in out. So this one and that one, these are both draining there, right? So I'm gonna select these two together, and I'm gonna merging them. Okay, then we have the total amount of water from both of these two, so there won't be any error in the calculation. That's the convenient, and then it will be activated. So now we are done. See, so how many sub watershed we have? 1 2 3, okay, 4 5 6 7 8 9 10, total we have 10. Okay, even what you can do, you can even export that. You can even export that watershed if you want to even calculate the basin average. That's what we'll do. That's what exactly we'll do, right? And what we have to do, we have to, so now our basin model is ready. See, our basin model is ready. I'm gonna even show that. See, our basin model is ready, everything is ready. We have that, see, and we have this method. If you want to even change the method here, see, loss method is by default initial and constant, and the transfer method, Clark unit hydrograph method, and base flow as recession. So I'm not gonna do that. I'm gonna change it for all. So that's why I have to click on basin and then go to parameter. Okay, go to parameter, and then what do we have to do? Start from there, canopy method. Okay, we're going to change the canopy method, and yes, and from none to simple canopy, then it will change everything for all of them. Okay, see, if I click there, you can see simple canopy, other simple canopy. Okay, so it's doing the same thing for all of them. You don't need to even click one by one and find that even yeah, it was creating even error. Okay, and then parameter surface, I'm not gonna select anything, and then loss method. Okay, I'm gonna even change it to which one, deficit and constant for this case, and it will change everything for, yeah, for every watershed or sub basin, and parameter, and then transform. Maybe it's already there, Clark. Okay, Clark unit hydrograph. Okay, it's already there, we can change it. And then what we have, and we have vase flow. Okay, I'm gonna even change it to linear reservoir in order to preserve that mass conservation. Okay, so now I have done everything. Even we can even specify our parameter as well altogether. We don't have to even select one by one. We'll do that. And let me fix it. Routing method, I'm gonna select that most popular one, masking gum. Okay, that one, we know that. And if there is any, let me check, loss and gain. No, we don't need to select that. So I think we are done with that. See, if I select any reach, we have that masking gum. Okay, and everything is connected, which one is downstream of which one is there, and it's pretty fast, right? We don't need to even check, okay, if it is connected or not. So that was the problem, and automatically see it already imported that latitude, longitude, and everything. So that's why I like that, and I think we are done with parameter setting, and we can even save it for the factor of safety. And then the next step is to, okay, I'll do that. I can assign that parameter as well by default for the sake of running the model pretty quickly. I'm going to show you that one, no problem. So for canopy, if you select now simple canopy, it is asking to even select those parameter. Okay, even I can show you that parameter, no problem. So initial storage, because what is the canopy? Canopy is basically comes from our vegetation or any kind of trees, right, from the leaves. So it is pretty normal. We don't need to even provide very high value. So the first one will be 0, and the most important thing of that canopy is that even if you want to even import all this value as 0, you don't need to even do that. Okay, if you click there, and if you click shift and then click there and right click and then fill, it will do the job for you. Okay, and it will it is filling everything for you. And next step is what, if you just maximum. Okay, maximum is also, it is in inch. So what I'm gonna do, I'm gonna give you 0.01, and same thing I'm gonna do here, and shift and there and right click and fill. So I'm just assigning for the sake of running the model, and crop coefficient is 1. It is not a problem. This is dry. And uptake method, it will be simple. So this time you have to select is, so it is extracting water. Uptake method means it will extract water from the soil, because this is related to the vegetation. So water will be extracted by the root of any vegetation. So that's the method. Even you can use tension. We are not going to use tension, because tension is basically negative pressure. And I'm done with that. If I apply, so it will do the job for every sub watershed or every sub basin. Okay, so that's, see, if I select there and canopy, see, the values are there. And for other one, previously what we did, we selected one by one and we did this same. Okay, now it's done for you. Okay, and now I'm gonna select the other method, as we're done with canopy. Now we're not gonna select surface method for this time. And now I'm gonna select loss method. What will be the loss method? Deficit and constant. Okay, for deficit and constant, what I'm gonna do, the initial deficit, it will be in inch, right? It is 2. Okay, 2 inch, and the maximum will be 8 inch. Okay, and the rate, if I want to use the rate, what will be the rate? Rate is 0.01 inch per hour, and I'm gonna use the same value as before. Right click and then fill, it will do the job for you. Click here and then shift and click and fill. See, it's pretty quick. You don't even need to click one by one and don't need to check everything because we are specifying the same data for all of them. Okay, so then close it. We are done with the loss method. Now what we have to do, we have to go to parameter again and then transform Clark unit hydrograph. If you select that one, and then we can even specify that number, what we need, time of concentration for each of this basin, and then storage. Okay, so I'm gonna expand it a little bit and then see. So I'm gonna select it like arbitrary I'm selecting, I didn't calculate, so I'll show you how to calculate that one. So I'm gonna run this model, that's why I'm selecting 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and 17. Okay, it may be opposite, I don't know, but I'm just selecting arbitrarily, and then that may be 8, 9, okay, 10, 11, 12, 13, 14, 15, 16, 17, and this may be also 10, I don't know, and then that will be 11. I'm just running the model. I'm showing how to run the model from DEM, and then in the next tutorial even I'll show how to even estimate the basin average precipitation, and then from that one I'll import and I'll show you how to calibrate the model as well. That's why I selected that streamflow location. I'll show you how to download that streamflow because I have the code, Python code. I've written the code that will download the 15-minute interval of USGS data pretty quickly. You don't need to even take that tension, and the default will be okay, it is as it is, and we don't need to do anything, and then apply, and it is done for all of them. Okay, now what we have to do, we have to even select the waste flow method and the waste flow linear reservoir. So since it is a linear reservoir, what do you have to do, we have to even expand it. We have a lot of things to take care there. Okay, the first one, so the layer, groundwater layer will be 2. I'm selecting that as 2. 1 is not good. Water will be divided into 2 layer in the groundwater, so that will generate basically the base flow, and is the linear reservoir. So initial that is CFS. Okay, if it is a CFS, so that's why we have to even assign, we have to calculate that one from different information as a default value. What I'm gonna do for upper level groundwater level 1, I'm assigning as initial value as 0. Okay, and then the fraction, what fraction of that value will be contributing to that base flow, so it will be 0.5. it is same. And what is the groundwater coefficient, we have to even select that in our, so it is 20. And for groundwater 2 level, the initial value for this case it is not even, it is 0.015. I'm just assigning this one. And what will be the fraction, the fraction will be same, but this case the coefficient for this one, it will be even 200. These are the default value we use, and then if I specify these are all 0, same way, right click and fill, and okay, then that is the same way we can even do that, shift and right click and fill, it will do the job for you, and 20, and then shift and click and right click and fill, and you are done with that one. Okay, similarly if you do the same thing here, see, it's pretty quick, but it would take a lot of time if we even follow the previous step. Even in order to create the basin model, it would take a lot of time. And now we are done with the basin model, we are done with even parameter, right? We selected the method, and now we are assigning the parameter one by one. So that is the thing where we selected, just let me check it pretty quickly, 2 layer of groundwater, and we are selecting that type, it is flow rate, but we have to select it as flow rate per area. That is more most convenient. Other people, they use that instead of flow rate. Then it will be easy. These are the experience, okay? People use this from experience, so you can do the same. And we are initial, okay, it's just con. Why? Oh, this should be 0.0, right? And even it is not selecting that one, okay, and that should be fill, okay, 0, and then everything is okay. And this one, this oh, since I changed the method, that's why it's just gone. It should be 0.015, and if I select it there, I'll estimate everything, but most of the cases you can keep it this way. These are the default value, you can keep it always, and then we'll fix the model while calibrating it. We don't need to change all of these values. This should be even default. Okay, I'm using this for a long time and I got these values from literature. So we are done with our basin model. Okay, let me check one. So we are done with a loss method, loss parameter. We are done with this transform. We're done with vase flow, and we are even done with canopy. So now we have to assign the parameter for reach. Okay, so again I'm selecting that basin so that I can do the same operation for everything. And routing method, it Muskingum is activated. I'm gonna do the same job for everyone. So that's that. So what will be the value of Muskingum K in hour? I'm gonna select it as 5, and since the value of X, we know that the value ranges from 0 to 0.5, so I'm gonna select the average value 0.25, and the sub reach I will select it as 5, and I'm just filling this as before. Click shift and click, right click and fill. Okay, I'm selecting this layer as 5 layer. Okay, 5 different segment. So this will be, these values will be divided by 5 and it will calculate that way. These are the routing mechanism. It will route and again it will start routing that. So these are basically this Muskingum method is called hydrologic routing method. There is another one, Muskingum-Kunz, that is called hydraulic routing method. So they basically use a part of that Saint-Bernard equation. That's why they exclude here a part of that, the diffusive part, the wave part. That's why it is called hydrologic, and if it includes that one, it is called Muskingum-Kunz, and that is called hydraulic routing method. Okay, I'm selecting and applying. So we are done with this one. So now what do you have to do? We are done with this basin model. Now we have to even add another component, MET model. Okay, meteorological model. I'm gonna give the same name as MET1 and then create. So I'm done with that, but we have to add that rainfall data, right? So we'll select those values. So if it is missing, then set to default, and evapotranspiration no, and we'll select the hydrograph, and it's done. We have to create that one. But next, what do you have to do? We have to select that control manager, and then it will be like control 1, where we'll specify our run time. Let me fix that first, then we'll calculate that one. So it will be like 22nd August 2017 00 hour, because that Hurricane Harvey, it basically started after 20th of August 2017, and the main severity was at the end of August, 30th of August and or 31st, and September 2, 3, or even up to September 5. That's why I'm gonna select 10th of September 2017, and the hour should be 00 as usual. Okay, and the downtime interval will be 15 minutes. That's okay. So we're done with our control. So based on this control specification, what do we have to do? We have to create our rainfall. Okay, so we need that 10 different rainfall gauges, but for this tutorial, or for now, only for the sake of running the model, I'll just arbitrarily create one time series, and I'll use for all of them, and then I'll run the model. But in the next tutorial, next part of this tutorial, I'll assign the exact value of the precipitation. I'll download the value and I'll show you how to generate the basin average, and I'll use the exact shape of this one. I'll export that one. I'll show you that. I have the script written in MATLAB and Python. I'll show that, and I can even calculate that one using model builder in GIS. I also have the process, same process. I'll show you that one. I'll download the data, either that NL does data, or even I can even use that latest version of MRMS data, multi-radar, multi-sensor data. So how to download this data, I have video already uploaded that one. You can even watch that. Okay, so now what I have to do, I have to even create that time series. Okay, I have meteorological model, and then I have to connect that time series precipitation with that meteorological model. Okay, so time series manager, it should be precipitation gauge, and it should be gauge or gauge 1. Okay, whatever it is, I'll use only one, so I don't have to be worried about that. Precipitation and the gauge, and then specify the time. What will be the time? The same time, 22nd of August 2017 002. Okay, 11th of September 2017, right? And what you have to do, gauge, and assign that it will be manual entry, incremental millimeter, no, yeah, incremental millimeter, and then it will be hourly. Okay, it is hourly data, and then we have to create that. You can see the table is empty and graph is empty. So this, in order to create that table, what do you have to do? We have to even select all of them and then copy. I'm just selecting dummy precipitation, not the exact one. I'm just creating here, and I'll paste it there. Okay, where's the value? Okay, let me copy that again, copy, and then let me paste. If it works, it should work, right? Why it's not working? Okay, maybe we have to select that way. I'm just selecting the time, that's why. Okay, I'm selecting the time, that is why it is just taking. I'm just dragging, and then it will work. Otherwise it was not working because it was showing on the text file. So I'm just creating the dummy, but I have the script that will automatically create that time series, the time and this one. So we'll import that one for 10 different sub watershed that we already have here, and we'll use the exact shape file to calculate the basin average precipitation. Okay, so now I'm gonna Control V. Okay, this time I have that. I don't need the time again. So what I'm gonna do at the beginning, I'm just selecting 10 millimeter of rainfall. Okay, 10 millimeter from August 23 to I think 24, and then it is kind of 50 millimeter. I'm just increasing it. It is arbitrary. I know the maximum value of. Okay, now we have the storm, so then it is okay, here it's not 50, up to 28 or 29. Okay, then maybe it's even 200. Okay, and it started 200, and then it was more than 1200. Okay, here, and then I'm gonna select it like 600 millimeter, but actually it was more than 1200. Okay, so it will continue up to this. I'm just selecting this way, and then it's like 400. It is decreasing now. Storm has already passed, and then it is not up to this one, like 5, and then it started decreasing, like again 50. Okay, and then it will be like even 10, and okay, and after that it will be like 10 millimeter. Okay, and then what I'm gonna do, I'm gonna select that. So we have the data for enter time. Now we can copy. Okay, what is that? We can. Okay, so let me go to all the way to the. Why it is not going? Do you have any missing value? Okay, wait. It should work. Why it's not? I'm gonna quickly copy that. Okay, copy everything. Okay, wait. Do we cover everything, or what happened? No, we have missing data, that's why. Okay, let me just cover up to that data, otherwise it will create even problem. 10th of. Okay, now it will definitely work. Okay, so I'm what happened? Control G. It is 10, right? 10, and I'm just gonna extend it all the way to there. Okay, not a problem. let me go back. These are the difficulties since I'm just generating the synthetic rainfall. Okay, and then Control C, I copied and I have to paste it there so that we have that time series. Okay, Control V. So now we can see the hydrograph. We can see we'll use that hydrograph for every watershed or sub basin. Then we'll run the model and we'll see if it runs really. Then I'll even accurately estimate everything in the next part of this tutorial. Now I'm going to show you how to create the complete model from DEM data. So main idea was to create the basin model and all this module here. Now we have to connect it, that MET model basin, we have to select this one, yes, and then if you select that hydrograph, then we have to select everything to gauge one, because we are connecting, we have the gauge, we connected it to our meteorological model, and then from this meteorological model we are just assigning, okay, we have this value of precipitation for this watershed or sub basin, for that watershed or sub basin. Since we are using only one, so we are assigning this one. So when we'll create the specific model and we'll estimate the specific parameter for each of this sub watershed or sub basin, we'll assign those separately. We'll give separate name by the name of the watershed or basin, and we'll do it. So I think we are almost done. Now what we have to do, we have to create the computation. Okay, so create that create compute and simulation run, and this will be like Harvey. Okay, Harvey, so Harvey run. So next it will take the basin model and it will take the MET model, it will take the controller specification, and now it's done. You can select here, see, and Harvey, and the bomb, this icon is now activated. If you click, if there is nothing wrong, then it will run, otherwise it will show the error. Let me, okay, it's running. We are lucky that it's running for the first trial. So I was really right that everything I specified is okay. Now we can see the result. If we click on the result and then double click here, Harvey, and then sub basin, you can see the map. See, it's pretty convenient. See the map. See the flow rate is too high, and the shape is like that because I specified that precipitation that way. That's why. And if I see at the sink 1, if I see it will be bigger than anything. See, it's huge. And actually it may be not like that, but the flow rate should be somewhat similar to this one. Okay, so that's why you have to understand how to calculate the runoff pretty quickly using our DEM data. If we have that, now we can even generate. Okay, so that's why I was really amazed with that latest version of HEC-HMS, and that's why I was thinking, okay, why don't I create one tutorial on that one. Now I'm done with that one, and I think, yeah, I'll even show you how to calculate the parameter, how to calculate the basin average precipitation, and how to calculate other model parameter. Then I'll run it again. So that will be the second part, or even if it takes, it will be the third part. But by this time it already, I think it's the video maybe more than 1 hour or not, I don't know, but I think this is okay for now. And you can even, because if you follow my previous video on ArcGIS, because I'm working on that specific region, so I downloaded every data, every possible data. I have the rainfall data, rainfall location, I have the USGS stations, everything I have, and I also downloaded the DEM. And how to download this DEM, I already uploaded the link. You can click that link, and I already demonstrated how to download those link, right, this DEM, and how to process this DEM, how to even extract this DEM for this study area, and how to project this DEM from WGS to state plane, and how to even change the vertical coordinate, unit from meter to feet. I already mentioned everything. If you are interested, you can check the previous videos. It is there in the ArcGIS playlist, and this will be added to my HEC-HMS playlist, and I have the previous tutorial on HEC-HMS as well. I'll link this video with that one. You can even watch that, and yeah, you can run this model. And if you have any query or question, or if you have any difficulties, because if you try, you'll face different problems, otherwise you won't face any problem. Because I had previous experience, and I even didn't work for a long time on this software, but I know how to do this because I know the basic thing. So that's why I was trying, and it's running for the first time. So that's that, and definitely is a new learning for me as well, and I think I'll be happy if it helps you all a little bit. Then I'll be really happy that okay, now the thing I'm just showing here, this is basically helping other student or other professionals or other future leaders and other people as well. So you have to increase your technical knowledge, and if you learn new thing and if you find this video very useful, then I'll be happy. And yeah, let me know in the comment box, and yeah, I'll see you in the next tutorial. Until then, stay safe and take care. Thank you very much for watching.